This is the performance task practice final. So task number 1, draw the line through the points -6, 1 and 6, -3. 1, 2, 3, 4, 5, 6, 1. And 1, 2, 3, 4, 5, 6, 2, 3. Okay, there's part A. Find the slope of the line. So my slope is change in y over change in x. 1 minus -3 over -6 minus 6, which gives me 4 over -12, which is -1/3. Write the equation of the line in slope-intercept form. I don't start in slope-intercept form. I start in point-slope form. Y minus, pick a y coordinate, doesn't matter which one. I'm going to go with 1. Y minus 1 is equal to -1/3 times x minus -6. And then simplify that to put it in point-slope form. mx plus b, that's what we're trying to get. Get rid of the double negative, distribute the -1/3. Y minus 1 is equal to -1/3 x. -1/3 times +6 is -2. And then I will add 1 to both sides. And I get y equals -1/3 x minus 1. Okay. Now, part C for part D. Rewrite this one in standard form. Standard form, ax plus by equals c. No fractions, no decimals. So the first thing I do is I multiply this entire thing times 3 to get rid of my fractions. You do that times 3, you end up with 3y is equal to -x minus 3. No more fractions. Everything in here times 3. And then I need to move my x's over to the other side, so I add x to both sides. X plus 3y is equal to -3. And it needs to be x, y equals number. If it's not in that order, it's not in standard form. So, part E, go back to the coordinate grid in the part A above, and this will be lined up above like what you have. And draw another line perpendicular to the first through the point 5,4. So the first thing, find the point 5,4. 1, 2, 3, 4, 5. 1, 2, 3, 4. There's my point. And if they're perpendicular, the slope of this line is -1/3. The slope of this line would be 3. Okay, perpendicular, opposite, inverses. So I have a slope of 3. So over 1, up 3. There's my line. Okay, perpendicular lines, opposite, inverse slopes. And then write the equation of the second line, slope-intercept form. So basically, I have to use the point 5,4 and the slope 3. Y minus 4 is equal to 3 times x minus 5. And then I have to rearrange that to put it in y equals mx plus b form. Distribute the 3. And then add 4 to both sides. Y equals 3x. -15 plus 4 is -11. And then rewrite that in the second line in standard form. Not a problem. All I have to do is move my x's over. I don't have any fractions, so I don't have to get rid of the fractions. All I have to do is subtract 3x from both sides. -3x plus y equals -11. Question? Second one. Sketch a parabola with a vertex -3, 1, going through the points -2, 2, and -5, 5. So, first thing you want to do, plot those 3 points. Vertex -3, 1, 1, 2, 3, 1, -2, 2, -5, 1, 2, 3, 4, 5. Vertex is either the very top or the very bottom. In this case, it's the very bottom. There we go. What is the value of the y-intercept? Come back to that. It's easy enough to come back to that. You were given 3 points. State one that's not on the parabola. Once again, I'm going to come back to that one. State the equation of axis of symmetry that I can do right now. The axis of symmetry passes through the vertex, and it's x equals the x-coordinate of the vertex. X equals, look, I told you, it's x equals -3, the x-coordinate of the vertex. State the vertex form of this parabola. This is what I want to do next. Vertex form is, come on, there you go, vertex form. Y equals x minus h squared plus k, where h is the x-coordinate of your vertex, k is the y-coordinate of your vertex. My vertex is -3, 1. So this would be y equals x minus -3 squared plus 1. Change that into a plus 3. State the standard form. Take the x plus 3 and square it out. So my first step in finding standard form is take this and square it out. Y equals x squared plus 6x plus 9. And then I still have my plus 1. X squared plus 6x plus 9 is x plus 3 squared. Still have my plus 1. Add them together. X squared plus 6x plus 10. And now we go back to these two. The value of the y-intercept. X equals 0 on your y-intercept. Anytime you have a y-intercept, you let x equal 0. That gives you the point of the y-intercept. When x is 0, that's your y-intercept. So you plug 0 into either one of these for x. Put 0 in the second one, it's easier. I get y equals 10. That's my y-intercept. Next one, you were given 3 points on the parabola. State one more point on the parabola other than the y-intercept. Basically, you pick any x-coordinate you want except for the 3 that are given and 0. So I can't use -3, -2, and -5. X can't be -2, -3, -5 because those were already given. And I can't be 0. I can use any other number I want other than those 4. The 3 that were given and the 0 that gives me the y-intercept. Any other x value I can use. Pick an easy one. Let x be 1. Plug it into either one of these. 1 squared plus 6 times 1. 1 plus 6 is 7 plus 10 is 17. Piece of cake. Okay, task number 3. Use the following equation to answer the questions below. State the maximum number of solutions to this equation and how you know you will have it. My maximum number of solutions is 3, because that is the degree of the polynomial. It's cubic. The maximum number of solutions I can have is the highest power on my x. Not the coefficient in front, but the exponent. Okay. rewrite this equation by factoring out the greatest common factor. So what divides into 3, 9, and 15? 3. X cubed, x squared, and x. Pull out an x, so I can pull out a 3x. And then what's left behind? 3x squared cubed, I took out 3x, I'm left with x squared. Negative 9x, I took out 3x, that leaves me with negative 3x. 15x, I pulled out 3x, it gives me plus 5, equals 0. You need to have both parts. The part you factored out and the part left behind. You give me one or the other, but not both, you're wrong. Okay, it gives me both of them. E and F, we need to come back to after this. So part C, after factoring out the greatest common factor, we have a quadratic. X squared minus 3x plus 5. Is it factorable? So I have 5 minus 3. Are there two numbers that when I multiply to get 5 and add to get negative 3? No, the numbers for 5 are 1 and 5, that's it. 1 and 5 will never add to give me 3. So this is not factorable. So that means, if it's not factorable, use the quadratic formula. A equals 1, B equals negative 3, C equals 5. X equals minus B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Notice I did not simplify. All I did was put the numbers in. Now I simplify. I didn't even simplify the negative 3. I just put the numbers in the formula. X equals 3 plus or minus the square root of 9 minus 20 over 2. 9 minus 20 is negative 11, right? So x equals 3 plus or minus the square root of negative 11 over 2. I cannot simplify the square root of negative 11. However, I can pull the negative out, and I get x equals 3 plus or minus I root 11 over 2. If I have a negative square root, got to pull out my I. Now, how many real solutions are there? How many imaginary solutions are there? So how many solutions did we say there had to be? 3. 3 solutions. These two numbers better add up to 3 or you're wrong. Okay? And yes, I say this because on the first time you saw this, many of you did not give me numbers that added up to 3. Okay? How many imaginary solutions do I have? I've got 2. 3 plus I root 11, 3 minus I root 11. There are 2 solutions there. They are imaginary because they have I, so that means I have 2 here. And imaginary solutions always come in pairs. This will be an even number, 0, 2, 4, 6, 8, 10. They always come in pairs. You never get imaginary solutions that are not pairs. So if I have 2 imaginary, and I have to have 3 total, how many do I have to have that are real? 1. Go by the imaginary. If you have imaginary solutions, put it in here. Whatever's left over goes there. Okay. And then this ought to look familiar. You are the lead architect for a new rose garden in Portland. You analyze the dimensions of available land on the hillside, and you realize you'll be able to create a design that has 41 rose bushes. The first row, total of 33 rows. You calculate that for each row, you'll be able to increase the number of plants by 5. Given this information, answer the following questions. Is this design best modeled using an arithmetic or geometric sequence? Yeah, it's arithmetic because we're increasing by 4 each time. When you're increasing by that, that means you're adding that number each time. So I'm adding 4 each time. This is arithmetic. Okay. Write the explicit equation and simplify it. A sub n is equal to the first number, how many are in the first row? 41, plus n minus 1 times what d is, the amount we're increasing by. And we're increasing by 5, so this would be 5. This is not the correct answer because you need to simplify it. Fully simplify your final equation. Distribute the 5. A sub n is equal to 41 plus 5n minus 5. A sub n is equal to 5n plus 36. 41 minus 5 is 36. And that is, you have to give it to me in that form. Notice that the number being added is not how many there are in the first row. Many people just assumed it was on the test you took. Do not make an assumption. Okay. So 5n plus 36. 5n plus 36, that's my formula. I'm writing it down because I had to switch to the next page. You should have that written down already. How many rose bushes will be in the middle row? The middle row is the 17th. 5 times 17 plus 36. That's it. That's what you do. Take the formula you came up with, plug in 17 for n. And you get 121. How many rose bushes in the last row? 33rd row. 5 times 33 plus 36. And you get 201 in the last row. How many total rose bushes will be in this design? Total of all the rows, or S of 33, the sum of the first 33. The total number of rows we have, 33, divided by 2, times how many were in the first row, 41, plus how many were in the last row, 201. And I get 3,993. Okay, questions?